So my name is Hans Kainz. I'm an assistant professor at the University of Vienna and the head of the Neuromechanic Research Group. The work I present here is the work done by my students, and I'd like to highlight two of my students, Lorenz Zweier, who did most of the experimental data collection, and Paul Kaufmann, who analyzed most of the data. As probably most of you know, one theory about how the nervous system controls movement is with the use of a few motor modules. These motor modules, which are also called synergies, are more or less co-activated muscles with a fixed spatial structure, which we can see here in this bar plot. So each bar represents the weighting of one muscle. Each muscle synergy has an activation pattern, which we can see here on the right, and this varies depending on the task demand. Several studies showed that impaired walking requires fewer synergies, or in other words, that the total variance accounted for one synergy is higher in people with impaired gait pattern. So which means like more complex movements require a higher number of synergies. Several other studies showed that similar tasks share synergies. For example, balancing versus walking, or walking versus cycling, or overground versus beam walking. We wanted to investigate if this is also true for more complex movements, and in particular, we analyzed skateboarding. So why skateboarding? Skateboarding is quite a nice example because it involves complex movements. It usually takes several months to years to learn new tricks, and the tricks are kind of different between each other, but they also share some goals, for example, getting the board up in the air. In these studies, we investigated 3 tricks. The first one is the ollie. It's basically just a simple jump with the skateboard, but I'd like to highlight that still it's one of the simplest jump. It usually takes people a long time to learn this trick, and some people start skateboarding and are never able to do a proper ollie. The second one is the kickflip, where the board gets rotated along the long axis of the board. And the third one is the 360 flip, where the board gets rotated along the long axis and the vertical axis of the board. As you can see from left to right, the complexity of the trick gets higher. So we wanted to investigate if the total variance accounted for one synergy differs between the tricks, if the synergies from a simple trick can be used to reconstruct the more complex tricks, and if the tricks share some synergies. We hypothesized that the total variance accounted for one synergy will be the highest in the ollie and gets lower with the more complex the trick is. We also thought that the synergies from a simple trick will not be able to reconstruct the pattern of the more complex trick. And we thought that the tricks will share a certain amount of synergies. In our study, we had 7 experienced skateboarders, and we collected as many trials as were necessary to have 6 successful trials. So of the ollie, kickflip, and 360 flip. We used the 12-camera Viking system and the 16-channel EMG system, and we calculated synergies based on the EMG signal using non-negative matrix factorization. So the time frame we were interested, what we can see here in the bottom, is like the x-axis is the time, and y-axis is the vertical position of the pelvis. And we analyzed the movement from the lowest position of the pelvis to the highest position of the pelvis, because this is the time frame where most of the trick happens. So if the person is already in the air, you can't influence what the board does anymore. We then calculated the total variance accounted for with the standard equations, which are known in the literature, and we calculated the number of synergies based on the threshold for the total variance accounted for of 90%. For the second research question, we used the F-min optimization in MATLAB, and we kept the synergies, so the weightings of the ollie, the simple trick constant, and tried to reconstruct the more complex tricks. For the shared synergies, we used 2 approaches which have been published in the literature, one based on Pearson correlation coefficients with a critical R value of 0.6 for 16 muscles, and the other one where we first calculated the maximum number of synergies across all participants, then we used uncentered correlation coefficient, and at the end a one-sided t-test with a critical R value to evaluate if there are shared synergies across all the participants. So what did we find? What we can see here is the total variance accounted for the front leg, the back leg, and both legs combined. In red, the ollie, in green, the kickflip, and in blue, the 360 flip. We found not much differences between the tricks. The only significant difference was for the back foot between the ollie and 360 flip, and for both legs combined, the ollie and kickflip. Surprisingly, the more complex trick, in this case it was the 60 flip and the kick flip, showed a higher total variance accounted for one synergy than the simpler ollie trick, which was against our expectation. Second research question, can we use the synergies from the ollie to reconstruct the activations from more complex trick? So here's the number of synergies which we had. So just to explain exactly what we did. For example, for participant 1, we took the 4 synergies from the ollie and then tried to reconstruct the activation pattern of the kickflip and 360 flip. Here we can see an example of one participant where we compare the ollie with the 360 flip. The gray shaded area are the measured EMG. The black solid line is the reconstructed EMG based on the 360 flip synergies. And the red dashed one is the reconstructed EMG based on the simple ollie synergies. And as you can see here, if you use the simple ollie synergies, you can't reconstruct the EMG pattern in a proper way. We also quantified this with the total variance accounted for, and for the kickflip as well as the 360 flip, we found a significant decrease in the total variance accounted for if you use the simple ollie synergies. So do the different tricks share synergies? What we found was that, so what you can see here on the left is the number of shared synergies for in red ollie versus kickflip, green ollie versus 360 flip, and blue kickflip versus 360 flip. And on the right side, it's just the percentage of shared synergies. So we found overall approximately 40% of shared synergies between the tricks, but we can also see here there's quite a high variability of the shared synergies if we compare ollie versus 360 flip, with one participant even sharing 100% of the synergies. And if you look at this, it is participant number 2, and this is the person who required the most attempts to do the trick. If we compare it with the second method to calculate synergies, we found quite different results. For example, there was no shared synergies between the ollie and 360 flip. For the other two comparisons, it was more or less similar. Another thing I want to point out here is like a research question which came into our mind while analyzing the data. Are more task-specific synergies better? So here we have an example, participant 2 on the left side and participant 7 on the right side, and we compared the ollie first row with the 360 flip second row. Participant 2, both of them used 4 synergies to do the 360 flip, but participant 2 had 100% shared synergies between the ollie and 360 flip, and participant 7 had a certain amount, 2 or 3 task-specific synergies. So participant 2 required 33 attempts for the 360 flip, and participant 7 only 9. So there's the question now, maybe more task-specific synergies are better, but at the moment we didn't investigate this into detail because we don't have enough participants for do that, but it might be an interesting research question to look in it in the future. So what's the take-home message? We showed that the total variance accounted for did not increase with the complexity of the trick. The synergies from the simple trick were not able to reconstruct the EMG pattern from the more complex trick, which goes a little bit hand in hand with our other observation that only a small number of synergies were shared between the tricks. Furthermore, we found high variability between participants, which might be related to the different skill levels. And our results are contrary to studies based on simple movements. And it might be that if you want to learn complex movement, you might have to develop more task-specific motor models and synergies. With that, I'd like to thank you, and I'm more than happy to answer any questions.
Great, thank you. There aren't any questions in the chat room, but I have a question. I'm just interested what you might expect in terms of the number of synergies if you were looking at a novice or somebody learning the tricks during that whole learning process. Would you expect it, to be initially a high number of synergies and then to have the reduction of number of synergies?
I mean, we didn't investigate that so far, but it's actually something we want to do in the future, not only with skateboarding, also with other movements, to see what happens if you learn complex movement. And I don't know exactly what could be, is that the number of task-specific synergies will increase, that you first use synergies you have from a certain similar movement, and then you develop more these task-specific synergies. But this is just an hypothesis, and so I can't.
Well, that's what I was really pushing you on, is what you think might happen. I know obviously that's not what you covered in your talk, but it all the way through I was thinking, well, you know, what happens during that motor learning process, and either using this particular idea of skateboarding or any other complex movement for that matter. And I was just, you know, I was looking for some parallels of trying to explore, as I said, that aspect of learning. Okay, a question from Laura Hutchinson. Why is it useful to know muscle synergies shared between different tasks or tricks?
Why is it?
So why is it useful to look at the synergies between the different tricks?
That's actually a pretty good question. Usually the question I get is, how can I do a 360 flip? Because many people skateboarded when they were young and never managed to do that. It is just like, for me, this is basically I started to look into synergies just like recently. And I only wanted to get an idea actually how we learn new movements, and especially more complex movements. So it will give us a little bit of an insight into how we control movements. But especially with the shared synergies, as you can see, different methods lead to different results. It's quite sensitive. And this is why I'm more confident with the total variance accounted for one synergy than with the shared synergies, because it depends on more parameters, basically.
Okay. I think that there's lots more there, but I'm mindful of time and we need to get on to the last speaker. So thank you so much. And perhaps you want to have a chat, go into the chat room and have further conversation. Okay, thank you very much.
Thank you, Jim. I was fascinated that a 13-year-old won the street skateboarding Olympic gold medal. So anyway, our last speaker today is